In this lesson, we're going to talk about adding and subtracting fractions. We're going to start out with fractions that have the same denominator. So all of the fractions on this page and the fractions that you see with the mixed numbers all have this same denominator. So it's nice when they do have the same denominator. It makes the calculations fairly easy. If fractions have the same denominator when we're adding or subtracting, then that means the answer will also have that same denominator. So I can tell that this will have a denominator of 6, and I can tell that this question down here will have a denominator of 15. Now that doesn't mean that my final answer will have those denominators, because it's possible that I might have to reduce. So I'm going to come up here, and now that I know what my denominator is, I can just focus on the numerators, and I have a -1 plus 5. I'm going to use my rules that I remember. They have different signs, so I'm going to subtract. 5 take away 1 is 4. And then I need to decide if this will be a positive answer or a negative answer. What's larger, a 1 or a 5? The 5 is larger, and it's positive, which means my answer is positive. Now in 7th grade math, 4/6 is not a good enough answer. It's not wrong, but it could be better, and it can be better by reducing it. I notice that 4 and 6 are both even, so I'm going to divide the top and bottom by 2, which will give me a final answer of 2/3. On this question down here at the bottom, I'm at the same point I was on the top. I know that my denominator will be 15, so now I can just focus on the numerators. 2 take away 7. Well, this is a positive 2. Didn't have a symbol in front of it, which means it's positive. I see different signs, so I'll subtract. 7 take away 2 is 5. Now I need to decide if it will be positive or negative. What's larger, a 2 or a 7? 7 is larger, and it's negative, which means that this is negative. And again, I can make my answer even better by reducing it. I can divide both the top and bottom by 5, which will leave me with 1/3. Don't forget that negative. Negative 1/3. On to the mixed numbers. Mixed numbers are a little bit tricky. When they have the same denominators, we can add the whole numbers first. That's pretty easy. 2 plus 1 is 3. And then I can add these two fractions. 3/4 plus 3/4, well, it's going to be a 4 on the bottom, and 3 plus 3 is 6. Now, this answer, not good enough. I can see that this is an improper fraction. And so I just need to figure out what 6/4 actually means. 6/4, well, 4 goes into 6 one time, and there would be 2 pieces left over. So I'm talking about 1 2/4, or even better, 1.5. So this piece right here, that's 6/4, actually means 1.5. So 3 plus that 1.5 is going to give me a total of 4.5. We need to be careful doing this type of problem in this way when we have negatives. And so in just a moment, we'll see a better way to do this might be to change these into improper fractions before we start. But there are some students who prefer to do this method. So we'll start again with the whole numbers. -6 plus 3 will leave me with a -3, and that's a whole number. And here's the part where students get mixed up. This whole thing is negative. It's a -6 and a -2/3. So when I go to do this second part of putting together the -2/3 and the 1/3, that's sometimes where students will forget that this part is actually negative. So if I want to combine these two fractions in the way I did up here in this example, I'm actually combining -2/3 plus 1/3. Well, I can see that the denominator will be 3, and I've got -2 plus 1. Different signs, so I subtract. 2 take away 1 is 1. And I need to decide if the answer will be positive or negative. What's larger, a 2 or a 1? 2 is larger, and it's negative, which means that this fraction is negative. So here's the part where I see that my answer then will be -3 and 1/3. They're both negative, so I add them together and keep the sign. I think a better way to do this will definitely be to change to improper fractions, and we'll see that coming up. Here now we have fractions that don't have the same denominator. And we've got two options for how we can deal with this situation. The first is to change these so that they do have a common denominator. And this is the method that you learned last year in 6th grade. I first look at the denominators of 10 and 5, and I see that 10 and 5 both go into 20. So I'm going to rewrite my problem with denominators of 20. And then I have to change this fraction into 20. How do I go from 10 into 20? That means I multiplied by 2, which means on the top I'll multiply by 2. 3 times 2 is 6. On this fraction, how did I go from 5 to 20? I must have multiplied by 4. I'll do the same thing on the top. 4 times 4 is 16. Now this is a problem that I can work with like those on the first page. The denominator will be 20. 6 take away 16 is -10, and I can reduce this to make a better answer, -1/2. Next problem right underneath it. I'm not going to finish this problem all the way. I'd like you please to finish this on your notes. I can change these into fractions with 12 as a denominator, and this fraction will still be negative. I went from 3 to 12 by multiplying by 4, which will give me an 8 up there. It's a -8. And I went from 4 to 12 multiplying by 3. And you can go ahead and finish this problem. Now this side talks about using something called the shortcut method. This is something that we're going to explore in class together. It's a great method, but I will make sure that it's something that you understand before you use it. So here's my challenge for you for tonight. I'm going to show you how to use the shortcut method, and then if you can come to class tomorrow with an idea of why this works. First, I'm going to do 2 times 3, which gives me 6. Then I'm going to do 2 times 8, which gives me 16. I'm going to put a subtraction sign in the middle because there was a subtraction sign. And for the denominator, I'm going to multiply 8 times 3, which is 24. And as an answer, I'm going to get -10/24, which I can reduce, make that better. Better answer, -5/12. So an extra challenge for tonight will be to be able to explain, why do you think this works when you come to class tomorrow? And I'll leave this problem here for you to practice why it works. See if you can copy those steps and make it work on this equation, or excuse me, on this problem, and see if you'll be able to explain in class tomorrow why that works. So here we are now with mixed numbers that do not have the same denominators. So what we're going to want to do is we're going to change these mixed numbers into improper fractions. And this is actually, I think, the best way to do this. If I could go back to that first page where they had common denominators, I think this is a much better method. There's less room for mistake. So the first thing that we're going to do on these is we're going to do our conversion, we're going to change this into an improper fraction by doing 3 times 2, which is 6, plus 1, which is 7. I've got 7 over 3. And I'm going to do the same thing here. 5 times 6 is 30, plus 3 is 33. And I keep that denominator of 5. Now this problem looks just like the problems on our previous page. You can either find a common denominator and solve, or you may use that shortcut and solve. And the shortcut, again, will make more sense once we do our investigation in class. I want to show how to change these as well into improper fractions. I'm not going to finish the problem. I'd like you to finish it. 7 times 1. And notice I said 1 and not negative 1. I'm just going to go ahead and bring this negative sign down, and I'm going to pretend it's not there. I don't use that when I'm changing to improper fractions. 7 times 1 is 7, plus 3 is 10. This is 10, and the denominator stays the same. I'm going to do the same thing here. I'm going to bring down this minus sign. 2 times 14 is 28, plus 3 is 31. And then use one of the methods you've learned to solve this problem. This would be pretty easy to use common denominators if you look at these. I could change this one pretty easily to match. Here are some more questions. We're getting really good at solving these when we're being asked to evaluate. Remember, evaluate means to plug in or substitute this value every time you see the variable m. Or plug in this value, substitute this value every time you see the variable n. Whenever I'm asked to evaluate, I'm going to do the same thing. I'm going to draw bubbles. I know bubbles is actually parentheses, but I do this m plus n so that I keep track of all my negatives. Here I'm writing negative bubble instead of negative m minus bubble instead of n. You'll see right now when I go back to fill in these values where it becomes very important. Negative 3/4, n is 2/3, and watch what happens right here. As soon as I plug in that negative 3/4, I'm going to remember something happens here. I remember seeing it in a lesson we've already done. And without those bubbles, I might have forgotten that negative right there. I'm not going to finish solving these. That's for you to go ahead and try. And if you finish, here's one more for you to set up and try on your own. You might also see some problems that have 3 numbers to be combined. In order to do that, you can actually just start with the first 2, pretend that this isn't here. So I would do negative 2/3 plus 1/4, negative 2/3 plus 1/4. And I'm going to come up with some answer. And then once I have that answer, then I'm going to go back and I'm going to finish this problem by taking that answer and subtracting 4/5 from it to come up with a final answer. Now this is a challenge for those of you that are ready for a challenge. These fractions have variables in them. Right here you can see that I have a variable, the letter d. Down here on a problem that you can try on your own, I have the variable x. Now these problems are just like all the other problems that we have solved. I need to worry about the denominators first. I'm going to turn these into the common denominator of 20, which means that my answer will have a denominator of 20. And now how did I get there? To go from 4 to 20, I must have multiplied by 5, which means I'm going to multiply by 5 on the top. 3 times 5 is 15. So this is 15d. How did I go from 10 to 20? I must have multiplied by 2. I'm going to do that same thing on the top. 2 times 2 is 4. with that d on it. 2d times 2 is 4d. And then I just do this subtraction. If I had 15 diamonds and I subtracted 4 diamonds, I'd be left with 11 diamonds. There's a problem down here for you to try on your own. This is an extra special challenge problem. You can remember to pause these videos at any time, especially on this page, so that you can copy down this website and go to this board game to practice adding and subtracting fractions. You'll notice the website is my last name, Carnes, AS Fractions, which stands for adding and subtracting fractions.